Alright, if you're in my class and you're watching this video, I strongly recommend that you have tried this problem. We're going to do it right now. Page 679, number 11. It's the first proof on the homework from 9.4. We're going to prove the sum of the first n even numbers. The purpose of this video is you've already tried it. Either you want to check your work, or you got confused, you were like, I can't do this, and now you're going to watch me do it, and hopefully then you'll be able to do the next one. So please, 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 if you haven't tried it yet, pause the video, go try it on your own. Alright, so we are given the even numbers. We are given an expression for the nth term of this sequence, 2n. We are given the summation formula we're trying to prove. This is what we're trying to prove. We got set up. We've taken these two values, the expression for a sub n and the formula for s sub n. We put them in, the things we always need to do one of these proofs. And now we're going to take n plus 1 and plug it in here and here and here. So when we plug in n plus 1, this first n becomes n plus 1. And when we plug in n plus 1 here, we get n plus 1 plus another 1, which becomes n plus 2. When we plug in n plus 1 here, we have 2 times n plus 1. We'll see if it makes sense to have it like that, or whether to use it as 2n plus 2. So now we have all the things we need, and we can start the proof. There's two parts to every proof by induction. The first is to show the sum of the very first term, which is just 2, basically that the first term equals what we get when we plug in 1 to this formula. So you do it manually, you find the first term is 2. And then you do it with the formula. Take this formula, plug in 1, and we've shown that the base case does in fact hold. These values are the same. Try not to erase anything. Once we've shown the base case, now we have to show the induction step. The induction step, always for a summation formula, says that if we know that the sum of the first k numbers is true, then we have to show that the sum of the first k plus 1 numbers is true. The sum of the first k numbers plus the very next number is the sum of the first k plus 1 numbers. You've heard me say it in each video. Think of this as being the sum of the first 99 numbers. K is 99. K plus 1 is then 100. The sum of the first 99 numbers plus the 100th number should equal the sum of the first 100 numbers. Take our values that we've already set up. N plus 1, n plus 2, n times n plus 1. And now which of those two expressions for a of n plus 1 is the better one? I actually like using the factored form, because now in one step I can do factoring by grouping. At first I was trying to prove this. Now we have shown that it is the case. And that is the end. Therefore, we have shown the proof. A small add-on, watching the first two videos that I just made, I noticed that I changed from k to n, and that probably confused some people. I shouldn't have done that. These should all be k's. The k and the n confuse people every year, and clearly I don't do it perfectly. I'm kind of lazy with it. But they are subtly different. N is any number. N is a variable that can be replaced by any number. K is some particular value. And so it's slightly different, but in my class, if you put n's or k's, I'm going to give you credit. I don't think that's the most important thing. I don't even feel like I explained it that well. But this would be the correct way to show this proof. I hope that's helpful on your homework. Please try the next one.